Bismillahirrahmanirrahim. So consider a binary code with 4 bits, 0 or 1 in each code word. An example of a code word is 0110. So how many different code words are there? And number 2, how many code words have exactly 2 zeros? How many code words begin with a 0? And number 4, in a constant ratio binary code, each code word has n bits. In every word, m of the n bits are 1 and the other n minus m bits are 0. How many different code words are in the code with n is equal to 8 and m is equal to 3? So let's begin the solution. So part 1, how many different code words are there? So this is a 4-bit word, right? With 4 bit, right? And each bit can be either 0 or 1. So each place can be chosen in 2 ways. It can be 0 or 1. The first bit can be 0 and 1, can be chosen in 2 ways. The second bit can be chosen in 2 ways. The third bit can be chosen in 2 ways, and similarly the fourth bits. So this is from the fundamental principle of counting: 2 multiplied by 2 multiplied by 2 multiplied by 2, and that is 16. So 16 words, 4-bit words are possible, right? And this can also be calculated by considering this as an ordered sampling with replacement, right? Each sample is ordered because if we change the order of the 0 and 1, then this is a different word. And furthermore, replacement is permitted, as 0 and 1s can be repeated in this 4-bit word, right? So this can be considered as, this can also be considered as ordered sampling with replacement. So number of words is equal to so these are two objects, 0 and 1, right? And we are taking them 4 at a time, right? So 2 raised to the power 4, this is again 16. Part 2, how many different code words are there? And part 2, how many code words have exactly 2 zeros? So if the number of zeros is 2 in a 4-bit word, then the number of ones is also 2. So we can solve this problem using multinomial coefficient. So how many code words have exactly 2 zeros? So code words, number of code words with exactly 2 zeros is given by the multinomial coefficient. This is 4, total bits are 4 and 2 are zeros and 2 are ones. So that is 4 multiplied by 3 multiplied by 2 factorial, and that is 2 multiplied by 1 multiplied by 2 factorial, and this is 6. The total words where exactly 2 zeros and 2 ones are there, the number is 6. So for example, these numbers can also be written down here. For example, 0 0 1 1, right? Then 0 1 0, right? And then 0 1 1 0, then 1 0 0 1, then 1 0 1 0, then 1 1 0 0. So these are the 6 4-bit code words, right? And part 3, how many code words begin with a 0? So we have 4 places, right? This is a 4-bit word, so we have 4 places. So this is filled. There is a 0 here. So this can be chosen in only one way. But it can be a 0 and 1. This can be chosen in 2 ways. Similarly, this can be chosen in 2 ways, and this can also be chosen in 2 ways. So using the fundamental principle of counting, this gives us 8, right? Total number of uh, total number of these words which begin with a 0 is 8, right? Now the last part 4. In a constant ratio binary code, each word has n bits. In every word, m of the n bits are 1 and the other n minus m bits are 0. How many different code words are in the code with n is equal to 8? So n is the total number of bits, right? Has n bits, and m is equal to 3, and m is the number of ones. So m is number of the ones, so number of zeros is n minus m. That is, in this case, 8 minus 3 is 5. So this can be solved using multinomial coefficient. So part 4, we are given n is equal to 8 and m is equal to 3. So n minus m, which is the number of zeros, 8 minus 3 is equal to 5. So using multinomial coefficient, the total code words of the given arrangement, given kind, is 8 factorial divided by 3 factorial and 5 factorial here. So this is 8 multiplied by 7 multiplied by 6 multiplied by 5 factorial divided by 3 multiplied by 2 multiplied by 1 into 5 factorial. So 3 factorial is broken down here. So this cancels out and this cancels with this. So this is 56. So 56 such code words are possible. 8-bit words are possible where the number of ones is 3 and the number of zeros is 5. So this concludes the solution to the given problem.